Morning. Today we are going to deal with open access same time information type system and open access in India. So why this OASIS? That means open access same time information system type system matters in India. So if you take like in Indian power sector, that is has been moving from the vertically integrated market. Previously, if you take like an Indian power system, it is all like a vertically integrated market. That means all the entities are in the single model. Generation, transmission, distribution, collection of tariff, everything is in the one entity. So after that, it moves towards the competitive market where generators can compete to sell electricity. Large consumers can buy directly from the generator companies, and the transmission and distributions are remain regulated. So the power flows must be transparent and non-discriminatory manner, such that if you take like in Electricity Act 2003 introduced this open access, allowing the eligible consumers to use this transmission and distribution network to to buy power from any seller. Okay, so in Electricity Act 2003, it was introduced this open access such that retail consumers are eligible consumers can use their transmission distribution to buy the power from any sellers, that means generation companies. So to make this work fairly, India is developing a digital and real-time information platform similarly to the Northern America's OASIS. So by seeing the Northern America's OASIS model, India also developing a digital and real-time information platforms. So what is this OASIS? That means in the Indian context. In India, OASIS is not a single national portal like US, but rather it is a conceptual framework. So implemented through state load dispatch centers, that means SLDC, regional load dispatch centers, and as well as the load dispatch, southern load and dispatch center, eastern load dispatch center, western load dispatch center, northern load dispatch center, and also which framing the central grid. Okay, so also this scheduling pointers also available here. So transmission utilities having the websites such that easily they can see what is the transmission power transmission is happening in the particular hour. Like that, you can easily monitor. And also, if you take like market platforms, the power exchanges, so that also there. Whereas the power can be traded easily. Say, for example, I am having a resource of 5 megawatt of power. I'm generating the 5 megawatt. So I don't know where I can sell the power. So if you go to power exchange, they can take my power, and based on that, they will give the tariff based on the current market. Next, national, due to the national digital initiatives also, this is being implemented. It is not like a US North America OASIS model. So it is also one of the conceptual framework similar to this OASIS. So the what is the main goal? Everyone, why this OASIS is being implemented in Indian context is so. We want the OASIS in Indian context is everyone sees the same transmission availability and rules at the same time. Okay, so what is the transmission availability, and also what is the set of the rules? That also everyone can easily monitor. Next, what are the main core functionality in India? So, what are the main function of this Indian OASIS-like system? So, it is not like same OASIS system. It is similar to OASIS-like system. What we are having in India is so. If you take like transmission availability, which displays the corridor capacity, interstate transfer capability, constraint outages, and all, and which helps the market players to know whether a transaction is feasible or not. And if you take like a non-discriminatory access, which ensures that private generators, discounts, distribution companies, traders, consumers are treated equally. as we discussed previously. So no one should give any consensus, consensus. So everyone will be treated as a same, like a request to go through formal digital portal, and also time-stamped approvals and denials also will be there here. Okay, so transmission availability also sometimes interstates will be there, intrastates will be there. So and also it will be displays the what is the constraints available outages today. Everything this availability will be showing. So which helps the marketplace so easily whether the my if I generate the power whether the transaction is possible or not, like that easily you can see. So, yeah, next it comes the transparency. So, the same information is released to everyone, which prevents the preferential treatment and also insider advantage. Okay, so insider, no one will get the advantage. So, whoever which is close to transmission companies, there, so their own generation companies are only won't get their contracts like that. So, anyone can be treated as a same. That means non-discriminatory access. So which prevents the insider advantage also, and also supports the competitive bidding. So whoever bidding for lower, they will get the contract for the power exchange market. Already we have discussed in detail about this power exchange market. Next comes the role of OASIS-type system versus traditional Indian operation. So if you take like a traditional system and as well as a digital OASIS-style platforms, data sharing. So previously in the traditional system, data sharing is only possible through phone, email, and manual like that. But with the digital OASIS-style platforms, web portals are available now. State load dispatch center website is available. Next, Southern Regional Load Dispatch Center, that also website is available. So, according to India, there are five load dispatch centers, like regional, state. Load dispatch centers are there. So that is Southern Road Dispatch Center, Northern Road Dispatch Center, Eastern Road Dispatch Center, Western Road Dispatch Center, Northeastern Road Dispatch Center. So in that website itself, if you go through that website, in that website itself, you can see all the data, like what is the today's load. So currently what is the frequency they are maintaining. That means hourly frequency also you can note what is the current system frequency they are maintaining, 50 hertz or 49.9 hertz, like that. Clearly web portals are available nowadays, and you can easily see say for a state load share, what is the state load share in that state, what is the generation happening by using thermal system, generation happening by using the hydro system, renewable system, everything clearly you can understand. Okay, so what are the frequency, what are the fax devices used, next extra any private participants are there, any government owned generators, what is the share, everything you can know easily by using this web portals and APIs is means what, application programming interfaces. So that is also you can use. Next is ATC visibility. Okay, available transfer capability visibility. In previous traditional system it is limited. Now public dashboards are available, so easily you can see whether what is the available transfer capability in the system, such that generation companies can increase their generation based on the demand. Next, application tracking. So previously in tradition system, like any application, say for example, if you are I am a generating companies, if you want to generate the power, previously it was like paper forms. So nowadays it is online workflows. All you have to fill a like that particular portal in the website. So easily set that application will easily fill, and that will be pop up to that particular authority. Easily they can give the approval based on the demand, and based on the current scenario they will give the approval in the instant, like 1 or 2 days you can get the approval. But previously you need to submit the paper forms. It will take consuming more time. Next, if you take like scheduling, previously it was semi manual. But in digital, like OASIS-based system, it is integrated softwares are available. Next, audit trials. Previously, it was weak. Now, digital logs are there. Easily, auditing is very easy and possible. Even consumers can also see whether the audited is correct or not. Like that, easily you can analyze. Next, market access. In traditional system, it was restricted. For a digital OASIS-style platform, it is open and competitive-based system. It is there. Next comes the Indian National Digital Initiative supporting uh, OASIS-like system. Like if you take like India Energy Stack, IES. So this IES is proposed as a digital backbone of the power sector. Similarly, how this Aadhaar card in India works, and UPI, like Unified interfaces. Okay, that also how it works in finance, like that. What are the main idea of this IES, India Energy Stack, is unique digital IDs for, they are giving unique digital IDs for generators, transmission line, meters. So consent based data sharing also available. So in that generator, what is the generation happening? So that data sharing directly you can get it to the web portals. So that is also possible. That is also happening in India after this Indian Energy Stack. So here open APIs are available. Real-time information exchange is possible. So I can even note down what is the current load, load demand, what is the current generation, what is the current frequency, what is the voltage profile, everything I can know in the websites. Okay, so like that they improved the Indian energy stack, which helps nationwide interoperable market. So interoperation also, say for example, interstates is possible, intrastates also possible, easily possible. Say for example, suddenly in one state demand is rising, in nearby state demand is somewhat nominal. So you can ask for the some demand, power demand, like power from the nearby states. You can import from that particular nearby states. Okay, such that easily you can utilize the demand. So you need to pay that whatever the tariff, whatever you are consumed, based on the whatever you consume, that you need to pay the tariff, whatever the set by that particular government, state government, or particular owned independent power producers. Next comes the digital monitoring and scheduling. So modern grid operation in India increasing depends on the special energy meters, ABT, availability based tariff meters and all. It is available. That will gives the like. So available base tariff, it will gives what is the current voltage profile. So what is the available, based on the availability, the tariff is being calculated. And like that, so power selling is also based on this available based tariff meters, special energy meters. It will sense the always the signal. So wherever you are fixing this special energy meters, it will always sense the what is the generation happening, what is the voltage profile, reactive power profile, volt frequency profile. So everything minute by minute, 15 minutes once, it is sending the data. So automated meter reading, AMR, 15 minutes block data. That I said, no, 15 minutes it is sending the data. So direct communication with the state load dispatch center, regional load dispatch centers. So in previously in India, 15 years, 20 years back in India, this regional load dispatch centers are now not framed correctly. So after that, they need to connect to national grid. for connecting to the national grid, they need to strengthen the state load dispatch center and regional load dispatch center. After that, they strengthened everything. Nowadays, all data you can get a minute by half an hour once you can get the data. 15 minutes once you can get the update. The data is being updated in the website. Say for example, now it is 9 a.m. in the morning. Okay, up to 8 a.m. in the morning, I can get the data. Like that, systems are there. If I'm having a login ID of that particular web portal, I can even see 5 minutes data, 15 minutes data also I can. But in website, they are uploading 1 hour after. Okay, so 9 o'clock data, 10 o'clock they are updating. Like that, it is also possible. Next is previous day data, today's data, like everything they are updating. So direct communication with the state load dispatch center, regional load dispatch center, and as well as transmission utility is also possible. So these replaces the manual meter reading and support, and which supports the accurate scheduling. Scheduling also accurately it is possible nowadays. AI-based scheduling also happening. Next, deviation settlement, congestion tracking, everything is possible in this data also. Next comes the government open government data platforms. So government digital portals now publishes the infrastructure statistics. What is the generation data? What is the current generators available? Okay, so everything it is publishing. Okay, so allowed federated data sharing also possible. Okay, support analytics dashboards. Okay, so what is the installed capacity of the generator? What is the current generator happening in that particular power station? Everything they are updating. So which improves the state sector-wide transparency also. It is possible in this government open government data platforms. Next comes the operational framework for open access in India. So operation. So who can apply? Say for example, if you take like a typical eligibility, if the connected load is greater than 1 megawatt, so it varies by state. They can also apply for this open access. Okay, open access. Some states allows for the smaller loads also. Okay, so step by step open access consumers or generators applies to the so if you are generating less than 1 megawatt also you can apply for this open access system. Say for example I am having resource of this much 0.25 megawatt, I can also sell the power. Like that you have to first of all you need to apply that I'm having this resources, I can provide the generation for this much hours, 8 hours of a day in a day. Like that, if I apply easily, that also possible in India. Okay, in some states, even for smaller loads, also they are allowed. So how this is happening? Step by step open access process. So if you take like consumers or generator companies are first of all has to apply to the southern load dispatch center that I'm having details of the source, sink, megawatt, so how much period I can provide everything. Next, you can also check the transmission and distribution feasibility also from your place. Say, for example, I'm having a mini hydel power plant, or I'm having a mini thermal power plant by using some waste. I'm burning that waste. I'm generating this much megawatt of power, 0.25 megawatt I can generate. Like that, you need to apply. Next, the meters, smart meters, you need to fix a scheduled, you need to schedule the issue from that particular state to dispatch center, which time you can schedule like that. Power flows, metered data will be collected, and after that monthly they will be settling your charges. Okay, not only monthly, sometimes weekly also. In some states the weekly, sometimes daily settlements also possible. Some states they are going for a yearly settlements. Like that, they are settling that charges also to that particular open access system. Next comes the infrastructure requirement. Say for the smart energy meters, availability based tariff meters, automatic meter recording. So automated meter recording. So this items. So these are the infrastructure they have developed. So communication links. They are using some GPRS, fibers, optio by using OFCs, and all they are sending the data. Next, meter data management system. Next, state load dispatch center interface. So if you take like smart energy meters or ABT meters, which records the 15 minutes energy blocks, and it is sending the data. Next, automated meter reading system. So automatically data will be uploaded to the system. Load dispatch center system. That means if you are running an open access, I am sending this much megawatt of power, 1 megawatt of power. 15 minutes once it will be updating. Okay, next, communication links. How this communication is possible? By using the internet only, by using some GPRS system or internet-based Wi-Fi-based system. Next, optical fiber cable. Data sending nowadays, it's very simplified, so you can easily send the data minute by minute, or 5 minutes once, or 15 minutes once, like that. So meter data management. So what is the main purpose is settlement. Okay, so for this much power is being imported, so that a particular load dispatch center will pay you the money for a monthly based, like that. Okay, next, state load dispatch center interface. That is also possible by what is the main purpose of this interface is scheduling. So, but if you want to integrate in your grid, you need to maintain the frequency as 50 hertz. Then only you can integrate or generate the power. Okay, even if you are generating by solar also, some inverters will be there. So that inverters will convert that DC supply to AC supply, and you need to maintain the frequency constant. Then only you can supply the power. Okay, so next, special energy meters are highly accurate. So typically zero point 0.2 SS class. Okay, and also microprocessor based solid state meters are also used to measure and record and store the energy parameters such as active power, reactive power, energy, next to voltage, frequency at 15 minutes intervals. So primarily used in Indian grid management system. They are using this nowadays. They are using this special energy meters. 15 minutes once it will be updating all the data in the Indian national grid. Next comes the settlements and charges. So participants, who are all participants, they are generating part. They need to pay the transmission charges, wheeling charges. They need to pay. Next, for connecting into the grid. For connecting into the grid, state load dispatch centers and as well as regional load dispatch centers, certain fee they need to pay. Next, gross subsidy surcharges, that also they need to pay. Next, additional surcharges, if any, that also they need to pay. Any GSTs, okay, that also they need to pay. Next, energy charges to the generators. Okay, so that also participants have to pay. So all process digitally. Okay, so whatever the energy that is imported to the grid, say for example, if I'm a individual power producers, whatever the energy transported to the grid, imported to the grid, so they will be paying monthly. And all. So all processes are being digitalized. Okay, digitally they will be sending the data, and based on that you'll be paid. What are the current challenges in India? Technical challenges, if you take, manual calculations are being done in some states. They need to make it fully digitalized model. But nowadays, some few states they are doing this. Next, incomplete ERP integration. Okay, portal integration, that some states they are not maintaining that properly. Okay, so they are updating late, 1 day after, 2 days after, weekly they are updating. Next, limited real-time ATC-based visibility, that is also there. Next, legacy supervisory control data acquisition system, and that is also that legacy the SCADA systems should be there. So next, financial challenges. If you take like a higher this charges, consume charges also there, additional surcharges also there. So make open access less attractive. So open access, to make the system open access, it is not advertised that much. Okay, only few places only they are maintaining. Some houses also they are constructing a small solar panel. They are also producing the power and giving to the grid. So that is also possible. That is also nowadays possible. Few houses they are doing that only in apartments. Okay, in flats and all, they are doing this. So it varies widely by the state. Next comes the infrastructure barriers. So costly meters, say for example, if you take like availability based smart energy meters, now it is meters are costly. Communication systems, properly communication systems should be there. IT upgrades also should be there for the utilities. That also they are maintaining throughout the India. So, but a few places they can't be reachable because of the remote locations and all. Next, cyber security requirements. That is also one of the important. Sometimes the data is being hacked and they are changing the data and sending. So that things and all they need to improve a lot in Indian system. Next, comparison of a North American OASIS and Indian-based OASIS-like system. So if you take like a North American-based OASIS and as well as Indian, we are comparing with these features like a standard portal. North America single standard portal is there. Okay, but in India still it is developing. It is not single standard portal. Generation one portal is there, transmission one portal is there, distribution one portal. So all together single portal they are developing. Next, regulatory driver is there. That means in North America, Federal Electricity Regulatory Commission is there. In India also, Central Electricity Regulatory Commission is there. Okay, so by using the Electricity Act, this Central Electricity Regulatory Commission was established. Okay, next, market maturity. If you take like in North America, it is advanced, but in India, it is still emerging. Next, if you take like availability based that capability posting, not America, it is mandatory, but in India, it is a partial. Only few places you can see this ATCs. Some few states they are not at all maintaining this properly. Next, automation level in North America high. In India, it is also moderate. Some areas, as I said, in some remote areas, this internet is not working properly. So data sending is taking some time. So updating is mismatching. So next, settlement speed. If you take like in North America, settlement speed is faster, and in India, it is a monthly based settlement. So in North America, like a daily based settlement will be there, weekly based settlement will be there. Sometimes hourly settlements also happen. But in India, it is monthly based. Next, AI integration. In North America, it is growing faster, but in India, it is in the initial stages, pilot stages only. AI integration is there. So still, India has to improve this all these factors and to maintain the OASIS system. So OASIS-like system is there in India. Still, it is evolving, but we are also have to maintain like North America based OASIS system. What are the future outlooks for India? So, like if you take like these are the directions in which we need to concentrate more. Like national level digital ATC dashboard should be framed. Next, integration with the India energy stack that is also should be made fully. Automation, more automation in the state load dispatch portals should be maintained. So in few states, even load dispatch centers inside the states will be there. Na? Regional load dispatch centers. They are all only main data only they are sending to state load dispatch. So that is not automated fully, partially automated. Next. Next, also depth also happening. Say, for example, communication device depth also happening in some parts of India. So that also they need to take it care of. Next, AI-based congestion forecasting, that also they need to taken care of. Next, reduced manual approvals. We need to manual approvals. We need to reduce mostly. So we need to go back to online platform, online based approvals has to be done. Next, harmonized state rules is there. Okay, so that also should be changed by the each and every states has to maintain a single code. That also they need to maintain.